Hello, this is the tutorial on 4.1b2, prime factorization. First of all, they want you to determine on a few of these numbers if they're prime or composite. Well, just remember that numbers like 3 that only have two factors, 1 and 3, these are prime numbers. If it has more than two factors, like 4 has 1 and 4, and then you can have 2 and 2, these are composite. So we've got composite and we've got prime. All right, so 45, well, 5 goes into it, so this is composite. You can just put down a C if you'd like. 51, well, 5 plus 1 is 6, so 3 goes into this one, so this one is prime. Oh, so this one is composite too. 3 only has two factors, so that one's prime. So you go through and identify those last 6 if they're prime or composite. And then find the prime factorization of each number. This is really the target for today. So prime factorization, I factored down, so I'm just going to move this guy over here so you can see a little more clearly. I'll write down 88. Well, pick any two factors that go into that, so I'm going to go with 11 times 8. 11 is prime, so that one's done. I can break 8 down into 4 times 2. So there's the prime factorization. Prime factorization is, whoops, break this one down. 11 times 2 times 2 times 2. So the prime factorization is just a string of primes, and all those numbers are prime. We have to write that in exponential form. So this is actually 2 to the third, because we have 1, 2, 3, so 2 to the third times 11. 124, that's a pretty big number, but let's pick two numbers that go into it for sure. We'll pick 124. We'll pick 2 and 62. Okay, well, 2 is prime, so we could just leave that. 62 is 31 times 2. 31, that's it. There's nothing else that goes into it. So the prime factorization of this one is 2 to the second, because there's 2 of them, times 31. All right. I'll do 165. I don't know what the prime factorization of that one is, but I know 5 goes into it, so let's do 165. So, well, 5 times 10 is 50. 5 times 20 is 100. 5 times 30 is 155. There's 150, and then we've got 3 more. So 5 times 33. Let's double check it. 5 30s would give me 150. 5 3s is 15. There's the 155. 5 is prime. There's no other number that can go into that. 33, I can do 11 times 3, though. And this is weird. It's a string of primes, but there's nothing we can combine. So 165 is just 3 times 11 times, oops, 3 times 11 times 5. Usually we put them in order from smallest to largest. 3 times 5 times 11. All right. And if you think about that, here, this is 55 times 3, which is also 165. So we know our answers, right? Okay, let's try factoring these algebraic expressions. This is a little more difficult. You can finish these ones up here by yourself. I've got you going on them. You might want to do them on a separate sheet of paper. So what can we factor out of 20xy? Well, we can factor out the 20 and say that that's 4 times 5 times x times y. We'll break that down into 2 times 2 times 5 times x times y. So I can combine all of that and say that that's 2 squared times 5xy. Okay? This is an interesting one. 44m squared. We can factor this as 4 times 11 times m squared times n. We can break that 4 down into 2 times 11 times m squared times n. We can combine it all and say it's 2 squared times 11 times m squared times n. Then you could take the multiplication sign out here at the end if you want. Or you could put it in up here if you want to. Okay, so just factor them out like that. Let's see. Scroll down just a little here. And take a look at number 26. Replace each blank with a prime factor to make the sentence true. Now this is a calculator target, and I think this is where I'm going to use the calculator. So basically what we're saying here is this is 4 times 7 times some letter, let's call it m, and that equals 252. Well, 4 times 7 is like 28 times m equals 252. So I can just divide by 28 on this and see what m is. So 252 divided by 28 equals 9. So this is m is equal to 9. So we could rewrite this as 2 squared times 3 squared, which is 9, times 7 equals 252. And then let's just run the numbers to make sure I didn't make a mistake. It's a complicated problem. That would be 4 times 9 times 7 equals 252. Bam. That's how we roll. All right. I'll let you look at the last couple of word problems on your own. This one's a little challenging, but go ahead and substitute the values in. You can do that. And this one's really pretty easy. It looks complicated, but just writing the prime of 440. Good luck. And I'm thinking a lot of kids are going to have trouble with this one here, so I'm just going to do it. Well, we just have to take, in place of the x, we're going to put these parentheses. And in place of the y, we're going to put these parentheses. That's the way you replace values. You always use parentheses. And so x is 2, so we're going to put a 2 in here. And y is 7. So we just do it. 2 times 2 is 14, plus 7 equals 21. So we're looking at 21. Is 21 prime or composite? Well, 3 goes into it. 2 plus 1 is 3, so this has to be composite.